Okay, so here are the success criteria for today. It's action-packed Tuesday. I can identify the quadrant of the Cartesian plane to which a coordinate biangle belongs. That'll make sense as we go along. I can determine the sign of a trig ratio based on the quadrant. So for this one here, we're going to be extending our understanding of trigonometry beyond acute angles to any possible angle. Last unit, we looked at extending it to obtuse angles between 90 and 180, but we'll actually extend it all the way through now. And really, that dot point there is saying, don't worry about what the value is. Do you know what the sign is? Do you know what the sign of the trig ratio would be based upon the quadrant? And told you it was action-packed. 3 more. Find the reference angle, given that theta is greater than pi on 2. Pi on 2, what's that again? 90 degrees. I am deliberately, even though it might mean a little bit of a cognitive overload to start with, I'm deliberately using radian measure as much as I can. It's more likely that you'll get radian measured than degrees, and you are so familiar with degrees already, it's the right thing to push you into thinking radians all the time, okay? So if you just remember that 2 pi is 360 degrees, then you can start splitting it up from there. So 2 pi is 360. That means half of that pi is 180, and half of that 90 is pi on 2, okay? So given an angle that's not acute, bigger than pi on 2, find the reference angle. Find the exact trig ratio of common angles. And that notation there simply means that theta is between negative 2 pi and 2 pi. So that means negative angles up to 360 and positive angles up to 360 at this stage. We are going to extend that further again, but that's just for today. So that's what that means. Theta is greater than or equal to negative 2 pi or less than or equal to 2 pi. So I always see those kinds of little notations as mean theta is between those two values. And find solutions for theta, for the angle, if given that theta is between 0 and 2 pi, given an exact trig ratio. Okay, so for example, it might be sine theta equals a half. What is theta? And you should be able to work that out. Okay, so before we do that, I'm just going to do a quick bit of reminder work, I suppose, on stuff we did from last unit. The first thing I just wanted to do is quickly go through that definition of sine and cos and tan based upon the unit circle. So the unit circle has radius 1 unit, and it's sort of, oh man, this is going to be so dodge. Ready? It's all right, it's not too bad. And it's basically if I circumscribed a circle in the Cartesian plane where the origin is the center of the circle, that's kind of what we'd be looking at. Anything along that dotted path there would be a coordinate of the unit circle, on the circumference of the unit circle. Okay, all right so far? This is just reminder work, so hopefully you'll be okay. Then we said for an acute angle, it would be in this area of the Cartesian plane. And we're going to call that quadrant 1. I'm just going to call that quad dot, but quadrant 1. Okay, and if we draw a triangle in quadrant 1, should be inside that circle, sorry. If we draw a triangle in quadrant 1, then we can see that sine of theta is going to be this distance here, and cos of theta is going to be this distance here, where theta is this angle in here. Okay, now that's not self-explanatory in itself, but I did explain it last unit. Does anyone need me to go through that in more detail? So cos theta is the x distance, sine theta is the y distance. And so we have sine of theta being the y coordinate, cos of theta being the x coordinate. And if you remember from a few of our explorations that tan theta equals sine theta on cos theta, then it must be that tan theta is y on x. So that's our new definitions. It's a coordinate on the circumference of the unit circle where the center is the origin of the Cartesian plane. Everyone okay with that? And I showed you pretty pictures last time, so there's no pretty pictures this time, just my dodgy drawings. Okay, so what we did, excuse me, is we then extended the idea into obtuse angles as well. We needed it for the sine, the ambiguous case of the sine rule, but in general, we needed it for the sine and cosine rule. We needed to know that there was such a thing as the sine of 123 degrees, recognizing that with standard trig, which is basically that, with standard trig, it doesn't make sense to define sine, cos, and tan beyond 89.9 recurring degrees. Okay, doesn't make sense to, because you can't create a triangle where there's an angle, can't create a right angled triangle where one of the angles is greater than 90 degrees. You just can't. Hopefully that's obvious. So let's have a look at the quadrants now. So what we did is, if we look at the Cartesian plane, then what we saw was that in the first quadrant here, so quadrant 1, based upon our new definitions, that sine and cos are just x and y. I might even zoom that out so you can sort of see both at the same time. Is that all coordinates in this first quadrant are positive. So x is positive and y is positive. Is that okay? Just based on basic coordinate understanding there. And in the second quadrant, that's this quadrant here, well, the x coordinate is negative and the y coordinate is positive. So everywhere in this quadrant, we have negative x and positive y coordinates. Moving on through the quadrants, in quadrant 3, we have x is negative and y is negative. So both of those coordinates are negative. And then in quadrant 4, we have x as being positive, but y is being y coordinates would be negative. Okay, so we have that arrangement of coordinates. Any questions about that? Good so far. I'm just unpacking it slowly, making sure that you're okay with it. Alrighty. So I don't know if you remember or not, but I'm just going to switch over to the other diagram, but I will bring this back up in a second. No, I'll draw on this one. So if I had an angle here, then the coordinate here is cos theta sine theta. We know that. And it's very well defined because it's in the first quadrant, which is basically an acute angle. So we know that from our right angle triangle work, then we would just get, for sine, it would be opposite over hypotenuse. For cosine, it's adjacent over hypotenuse. And for tan, you can either use sine over cos or you can use opposite over adjacent. So it's very well defined over here. But if I then look at, yeah, sure. If I then look at an angle over here, like so, this would be an obtuse angle taken from the x-axis, and we would have the same angle in here. So this would be 180 minus theta, and this angle would be theta here. So effectively, the ratios will be the same on this side, except that the x-coordinate will be negative. Okay, so the x-coordinate is negative on this side. I'm just going to rearrange this now a little bit. So I'm going to undo all those steps. Yeah, ask away. Sure. Okay. So what we do is we say this is angle theta. It is an obtuse angle. It's between 90 and 180. I'm going to zoom up on that. This angle here is what we call the reference angle. I'll draw it in blue. And it's the same symbol, but we put a little hat on it. And you can actually call it theta hat. Okay? So this is called the reference angle. It's always acute, and it's effectively the quad 1 equivalent. Okay? So it's so the sine, cos, and tan of theta is going to be the same as the sine, cos, and tan of theta hat, except that the coordinate system will affect the sign of the value. So if I knew that the sine of 16 degrees is 0.2, I don't know, just making it up. So I could say that for the sine of 180 minus 16, so what's that, 170, 164. So if this was 164 degrees, I'm saying that the sine of 164 degrees is the same as the sine of 16 degrees, but then we need to check whether it's going to be positive or negative. Okay, so the reference angle tells me what the value is, and the size of the angle and which quadrant it rests in tells me what the sign of the value is. So let's have a look at that. Sine theta is equal to the x coordinate. So that means that sine is positive in the first quadrant and the second. Sorry, I've got that in the wrong way, haven't I? Sorry about that. The first quadrant and the second quadrant, because the y coordinate is positive in those two quadrants. Does that make sense? Okay. Cosine is the x coordinate. That means that cosine is positive in the first quadrant, and you've got a 1 in 3 chance of getting it right. Which one? The fourth quadrant. Okay, because x is positive here, x is positive here, but x is negative over this side. Now, tan theta is a ratio of the other two values. So remembering that tan is sine on cos, then we have y over x being the value of tan, and so we need to look at the division. So when I divide a positive y by a positive x, then I'm dividing a positive by a positive, and I'm getting a positive. So it's positive in quadrant 1. When I divide a negative by a positive, the result is negative. So tan is not positive here. Similarly here, I'm dividing a positive by a negative, so it's negative overall. But in the third quadrant, tan is negative y over negative x. And when you divide two negative numbers together, the result is positive. And so that means that tan is positive in quadrant 3. Okay, so you can see that sine, cos, and tan, by our unit circle definition, sine, cos, and tan are always positive in the first quadrant, and then they've carved up the other 3 quadrants between them. Sine, then tan, then cos as you're going clockwise around. So all trig values, then sine, then tan, then cosine, and that covers all 4 quadrants. Now, in terms of an aid to memory, the one that, diagrammatically, it's called a cast diagram, but I don't remember it like cast. I remember it like this. There's an A in there for all trig values, an S in there for the sine values, a T in there for, thank you, for the for the tan values, and the fourth quadrant, it'll come up in a second, are the cosine values. Now, this is how I learnt it. I learnt this as, starting from the first quadrant, all students take care. Okay, so that's your aid to memory. All students take care. Another one I've heard is South Australian Technical College. That's just a left to right aid to memory. It's called a cast diagram because if you start in quadrant 4, it makes the word cast, C-A-S-T. So that's your cast diagram. Now, I remember all students take care, but you choose whatever you want to. You make up your own. But importantly, if you can remember where sine, tan, and cosine is positive, then you're good to go. P.S. I didn't say this explicitly, but is it okay if we see that sine is the only one that's positive here? Therefore, cosine and tangent is negative. Similarly for these other two areas as well. So this is the only trig ratio that's positive. So that means that if you've got angles between 0 and pi on 2, then the sine, cos, or tan of that angle has to be positive. If you have an angle that's between pi on 2 and pi, then that means that the sine of that angle is positive and the cosine or tangent of that angle has to be negative. Yeah, of course you can. Between pi and 3 pi on 2, so in this area here, that means if you've got an angle that goes from here all the way over to here, then that would be tan being positive and the others being negative. And if you have an angle all the way over here, then that means cosine is positive and the rest are negative. And that's how it works. Now, this definition will work for any possible angle. And I'll get onto negative angles in a second, but I'd like to sort of maybe just talk about a couple of, there's one other identity I forgot to mention actually. I'm going to go back and just do that because it's going to be important for some of our solution writing. An identity is a relationship between trig functions that always works. And I just wanted to point out that we did look at this last unit, that due to the nature of the right angled triangle that is formed here, and it works here as well and works down here as well, we have, by Pythagoras' theorem, we have this squared plus this squared must equal the hypotenuse squared, and the hypotenuse is just 1. Okay, so sorry, I forgot to say that before. So the other important identity for today is that when I square sine theta, do you remember we did this notation? The square goes just after the function, but it means square the result. And I square cos theta, then I get 1. Okay, always, 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 because of Pythagoras' theorem. And we can see it I'm going to erase this, but we can sort of see this really quickly. We know that the sine of 45 degrees is equal to 1 on root 2. We know that the cosine of 45 degrees is 1 on root 2. And sure enough, 1 on root 2 squared plus 1 on root 2 squared is equal to a half plus a half, which is equal to 1. So it does work, and it works for any angle. Even obtuse angles, reflex angles, negative angles, it still works. I'm only showing you in the first quadrant, but you can take it as given that it works for the rest. Alrighty, so that's where we're up to now. We've now extended our definition to all 4 quadrants, and in fact, we've extended it to all possible angles because anything above 360 is just going to be a rotation that's at some stage ends in one of those quadrants. Okay, please undo. Or if we go negative, it's the opposite direction, but I'll talk about that in a few moments. Alrighty, so a couple of special values we should look at, which we haven't really, and that is, well, what does it mean when theta is equal to 90 degrees? Because that's not defined under right angles. But if we use our coordinate system, we can sort of see that happening fairly decently as well. So if I look at, say, for example, the sine of 90 degrees, pi on 2, well, what does our coordinate system tell us? Our coordinate system says that 90 degrees would be there, and that the sine of 90 degrees must therefore be whatever the value of the y coordinate is. Well, since the y coordinate is constrained by 1 unit, that means that it must have a distance of exactly 1 unit up the y-axis. So that means that the sine of pi on 2 is equal to 1. All right? The cosine of pi on 2 is equal to what? Well, at 90 degrees, what's the x-coordinate? The x-coordinate has come all the way back down to the origin again, so there is no movement along the x-axis, so that means the x-coordinate will be 0. And because the x-coordinate is 0, that means the cos of 90 degrees is also 0. Okay? And the tan of 90 degrees is equal to y over x. That's y there. That's x over there. 1 divided by 0 is undefined. Yep. Okay, you cannot divide a number by 0 and still exist in the real number plane. Alrighty, so that's 90 degrees. I might just verbally just talk about the other coordinates so that you've got a feel for it. So 0 degrees, we would have cosine being at 1. So the cosine of 0 is equal to 1. The sine of 0 is 0 because there's no movement in the y-axis. And the tan of 0 is 0 because 0 divided by 1 is just 0. Okay, so that's okay there. I'm not writing them down. I'll leave it for your own edification to write down all the values for yourself, or perhaps if you remember the cast diagram, you'll be okay without writing them down. If we were talking about 180 degrees, which is pi, then we're looking at here somewhere. So we would have the cosine of pi being -1 because we've gone back 1 unit here. The sine of pi would be 0 because there's no movement along the y-axis. And the tan of pi would be 0. Okay? And then for 270 degrees, which is 3 pi on 2, the sine of 3 pi on 2 would be -1 because we've gone down 1 unit along the y-axis. The cosine of 3 pi on 2 would be 0 because there's no movement along the x-axis at this point. And the tan of 3 pi on 2 is again undefined. So as long as you remember how the trig values correspond to the Cartesian plane, limited by the fact it's on the unit circle, then you are pretty much good to go. Okay, so you can memorize a whole heap of values, or you can just sort of remember those edge values, how they sit on the plane, and then just deal with the ones inside, like pi on 2 and all that pi on 4 and stuff like that. Okay, so that's the extension to those ones. What else? Okay, try this one just in your workbook and see how you go. This is without me explaining anything at all. So don't stress about it if you're not even too sure how to start. I'm not going to come around and help you. I'm just going to give you just a minute to see whether you can work out what the value of sine of 5 pi on 4 is. I'm going to give you the steps down here though. Should say no calculator. Sorry, I should have said that. No calculator. I want the exact value. that's what you're doing. Now, longer term, you would be, I'd expect you to be able to do these 4 steps in your head effectively. I'll write a solution out in a second. One thing that always bothered me when I first started doing these extended trig value kind of things was, how do I draw the triangle? Just note that the angle is always expressed as being a certain distance away from the x-axis. So you never look at the reference angle as a value between the y-axis and the line. It's always between the x-axis and the line. Always, always, always. It's either above or below the x-axis, or on, I suppose. And in case it wasn't really obvious, the angle is always taken from the positive x-axis. So this is always 0 degrees or 0 radians here. Always, always, always. And it's always taken, a positive angle is always taken in a counterclockwise direction. Okay, either you've got it or you haven't. I'm going to take it one step at a time. So it's 5 pi on 4. So 5 pi on 4, I can see, is above pi. Okay, there's more than 1 pi there. It's 5 pi on 4. So there's pi there, 180 degrees. And I know that 3 pi on 2 is somewhere, is right here. And 3 pi on 2 is equal to 6 pi on 4, just by multiplying top and bottom by 2. So I know that 5 pi on 4 must be in this third quadrant, beg your pardon. It's a third quadrant angle. So when I draw it, I'm just going to, it doesn't matter if you don't know what pi on 4 is yet, but just know that it's in here somewhere. Okay, so that's theta, 5 pi on 4. This angle here is the reference angle then. This is theta hat. So I need to see how much more than 180 is 5 pi on, what's the difference between 180 and 5 pi on 4 effectively. Gee, I'm mixing it up there, aren't I? So I do something like this. I say that 180 plus the reference angle must be 5. Oh my gosh. Look at me. I'm so sorry. Pi plus the reference angle must be 5 pi on 4. Okay? So therefore, theta hat is equal to, and you could do this in one step, I'm just spelling it out for your notes really, is equal to 5 pi on 4 minus pi, which is equal to pi on 4. Now, you stop there and you need to make sure that what you're left with is an acute angle. That means it needs to be between 0 and pi on 2. If it's not, you've made a mistake. So go back and check your working out. Okay, so that's step 2 done. I've worked out the reference angle. Theta hat is equal to pi on 4. You okay with that? Oakley dokley's. So that's that bit done. The third thing is to find the exact value of the reference angle, hoping it exists. In this case, it does. I chose it deliberately. Sine of theta hat is equal to root 2 on 2. Is that okay? Because pi on 4 is 45 degrees. Can you see how easier it's going to be if you actually know your angles, your trig ratios for these things? Therefore, that's step 3. Therefore, the sine of 5 pi on 4 must be negative root 2 on 2. There we go. So effectively, that's step 1, that's step 2, that's step 3, and that is step 4. No, not at all. I'm spelling it out for your notes so that when you go back, you can sort of see the steps. But if I was doing it in my head, Izzy, I would probably, unless I can visualize the angle really well, and it's not all, I'd probably draw the diagram probably, just to make sure. I would then just work out the reference angle just by the diagram. So I'd say, oh yeah, I can see that. It's pi up to there, so it's pi on 4. Okay, so I'd make a note to say pi theta hat is equal to pi on 4. I'd probably just do that straight up. And then I would pretty much go do this bit here, I reckon. So rough diagram, quickly notated, notating the reference angle, and then notating the final answer. Okay, and the reason why it's a negative is because it's quadrant 3, and quadrant 3 is where tan is positive and sine and cos is negative. Alrighty, any questions on that one? I'm going to give you one to try by yourself now properly. Can you try this problem? You've got the steps up there. So tan of 7 pi over 6. And see how you go. You got your 4 steps there. Part of your cognitive load is, and I get this, it's going to slow you down because you're thinking about it, is, well, if I said to you tan of 330 degrees, that's not 7 pi and 6, tan of 330 degrees, you'd know exactly which quadrant is straight up, right? It'd be 4th quadrant. So don't be dismayed by the fact that your brain is slow at working out where something like 7 pi on 6 is. That's no biggie at the moment. You just need to keep on practicing with radians and don't give up until you become really flexible with your thinking. It's like learning a different language, I reckon, after a while. Like when I learned Italian for quite a while, I started just using particular Italian words when I was writing, like e for and stuff like that, simply because when I saw et by itself, I knew it was and it was shorter to write et than and when I was doing stuff. And so I would do that occasionally. And you can just start thinking in the language that you're really familiar with. And similarly with radians, the more you practice with them, the more you use them, the more flexible. You're not going to have to go pi, that's 180 or anything like that. You're just going to be able to say, you're going to know that pi would represent half a turn, 2 pi would represent a full turn, and all that kind of stuff. Just another minute or so to do that. While you're waiting, can you please try this one? Again, I haven't shown you how to do this. How would you do that one? I saw a couple of you just flicking back to look at your chart of your table of values. Perfectly fine. From what I can tell, you don't get those values on the exam. So you're going to have to memorize them between now and, what is it, October, November? But yeah, keep looking at them. I might have to do an exact trig ratio Kahoot to play, I think. Sure. Okay, if you're still doing tan 7 pi on 6, I'm about to go through it. So finish up as best you can. So step one is to work out that quadrant. So again, I'm just uncovering the thinking that you might do in your head. So I know that theta, or 7 pi on 6, is going to be beyond pi, but only just. 7 pi on 6 is just above pi, isn't it? 6 pi on 6 being pi. Wow, it's amazing. Like, if you don't know your fractions that well, I can imagine how difficult this would be at this stage. So that would be roughly 7 pi on 6. So I'll just notate the diagram. So I've got that. So it's the same quadrant as before, isn't it? So the reference angle, theta hat, is going to be equal to 7 pi on 6 minus pi. So I'm just looking for that little difference there, that little extra. So that's going to be pi on 6. So that's 30 degrees. Tan of theta hat is equal to root 3 on 3. That's the first quadrant angle, the reference from the reference angle. And therefore tan of 7 pi on 6 is also root 3 on 3, because tan is positive in the third quadrant. Okay, I hope that makes sense to you. Izzy, question or just stretching? Did anyone get what theta is? What'd you get, Izzy? Good, you've got 2 solutions there, which is really good to see. Okay, so we need to recognize that sine theta is equal to a half. We look at the sign and we see that half is positive here. So if sine theta is positive, we need to work out what possible angles would give us a positive a half. And the answer is, well, in our cast diagram, just going to flick to the page before, all students take care, we can see that sine is positive in the first quadrant and sine is positive in the second quadrant, like so. So effectively, when we have a positive value, well, regardless whether it's positive or negative, the first step we do when we're trying to find out what theta is 1, ignore the sign, work out the reference angle. Now, it could be that the reference angle is a solution, but it could be that it's not. So ignore the sign, work out the reference angle. Number 2, now check the sign, work out the quadrants. Number 3, add or subtract the reference angle from as appropriate. Okay, so remembering that you will always be taking the reference angle from the x-axis, we've got sine theta is equal to a half here, so we need to work out what angle in the first quadrant would sine theta be, and then what angle in the second quadrant would sine theta be. So I'll have to do the solution on, and I'll try and squeeze it in there. It's a bit dodgy, but we'll see how we go. So in terms of the diagram, the reference angle would be theta hat is equal to, so we look it up on our chart and we see that theta hat would be equal to pi on 6. Okay, so that's step 1. Then we need to work out, checking the sign, which work out the quadrants that theta must be in. Okay, so I'm going to spell this out. You probably don't need to be so formal as I'm about to do. Okay, So since sine theta is positive, sine theta is in quadrant 1 and quadrant 2. Okay, I'm just going to have to go to the next slide. Sorry, that's really mucky. In quadrant 1, theta is equal to the reference angle. And in quadrant 2, oh my goodness, in quadrant 2, well, what does theta equal? Let's just have a quick look at it. I might even go back to this one here. In quadrant 2, the angle is going to be somewhere in here. Remember that the reference angle is back here. So we've worked out that the reference angle is pi on 6. The reference angle is pi on 6. And so therefore this angle here would have to be 180 minus the reference angle. So it's 180 minus theta hat. So the angle is 180 degrees, pi minus the reference angle, which is pi minus pi on 6. And pi is 6 pi on 6. And so pi minus pi on 6 is 5 pi on 6. And there we go. Oh, sorry, I should have stuck that in there. And I wouldn't normally do this, but I'll just do it for your notes, i.e. theta is equal to pi on 6, as Izzy said, or 5 pi on 6. So 2 possible solutions. Now that's, to be very clear, for theta being between 0 and 2 pi. Okay, it's between those two values, because we could actually go beyond 2 pi and before 0 in order to get even more solutions, but we'll cover that in a different lesson. But they are the two possible angles between 0 and 2 pi. Okay, so just a reminder that when we have an equation like sine theta equals a half, then what we're doing when we're solving for theta is we're saying, what possible values can I have for theta which makes that equation true? So sine of what equals a half, and then we've answered it with our solution right there. So there's step 1 there, like so. There's step 2 here, like so. And then over the page, I'm sorry to be a bit zoomy here, and this is step 3 here, like so. Okay, let's give you a couple more to try, and we'll see how you go. Try and do enough setting out so that your solution is clear. So I'm going to go for cos theta is equal to negative a half. What is theta? And then tan theta is equal to negative 1. What is theta? So I'll give you just a few minutes to do that. I think I'll leave negative angles to next lesson because I've spent a bit too long with my explanations, although I hope you've had a little bit of practice time just as you've been trying to work stuff out. But I'm just going to write down, because I know that some people will finish those faster than others, so I'm going to write down what I want you to have a go at. But just note that some of the problems that you've got in exercise 13A, which is where you're going to be headed, are negative angles. We'll deal with that next lesson. So I'm sorry, I don't have a page reference, but it's exercise 13A. And I want you to try every second problem. It's not a very long exercise. So that's after you've done the 2 on the board there, which I'm going to go through in about 2 or 3 minutes. Okay, there's cosine for you. See if you can follow the working out there. Okay, so we've got 2 minutes before the end of the lesson, so I'll just quickly go through those solutions. They are written up there, so if you did get them right, then you can be pretty confident on that one. So again, I might even just zoom up so we can sort of just focus on that particular one screen. So we've got work out the reference angle, cos of theta hat equals a half, and therefore theta hat equals pi on 3. You just need to know these things. If you don't have a calculator, you just need to know them. So use flashcards, whatever process you need in order to memorize a whole bunch of facts. So there's theta hat equals pi on 3. Very quick cast diagram to work out, well, I know that cos theta is negative a half, so it's less than 0. So where is cos negative? Cos is negative there and cos is negative there. What does that look like? Well, that means it must be pi minus the reference angle or pi plus the reference angle, and that's what we've got there. And for tan of theta, the reference angle is pi on 4. For tan of theta less than 0, tan would be negative here and tan would be negative here. And therefore, I must have pi minus the reference angle, that's there, or 2 pi, that's a full rotation around, 2 pi minus the reference angle. So 2 pi is 8 pi on 4, so 8 minus 1 is 7 pi on 4. Okay, just to finish off the lesson, it isn't quite 20, it is just turned 25 past. Let's just move back to the success criteria. And again, in your head, rate your confidence on each of those dot points. And if you're feeling not confident, then what's your pathway to success? What are you going to do next? Can you identify the quadrant of the Cartesian plane to which a coordinate belongs? Can you determine the sign of a trig ratio based on the quadrant? That's what we spend the bulk of this lesson looking at. Do you think you'll be able to find the reference angle if theta is bigger than 90 degrees? Do you reckon you can find the exact trig ratio of common angles given theta between, maybe not between negative 2 pi, but maybe between 0 and 2 pi? And can you find solutions for theta being between 0 and 2 pi? If the answer is no to any of those, that's where you're at, and you now have you can chart your own pathway to success from that point. Okay, more practice next lesson.